that's the one I'm going to focus some time and attention on, is this one. They're all set up the same way. They are kind of story problems in a way. And what I like doing is writing the equation out. So if you don't write the equation out, that would be something that would be very beneficial to do. I know it's written out in the book, but what it does is it allows you to kind of act like a guide, where you are at and where you need to go. So the book will say, the problem says you have 0.046 moles of lithium bromide. How many moles of lithium chloride do you need? So there's chlorine, there's bromine, there's lithium chloride, and there's lithium bromide. So if you're not very good on your names, then that will become a problem of kind of understanding what you're trying to solve for. So all problems, every single problem you guys are going to do in this unit involves a mole-to-mole problem. Every single one that you do, somewhere in the setup, you're going to have to do a mole relationship. It's kind of, moles are a translator between grams. So we're given grams. Later on today we'll be given grams, or we're asked to find grams. And moles as a translator allows us to move throughout the equation to solve for different amounts. But we have to go through moles to do that. So very important that you write your units in and you label your formulas. If you don't, you're going to get lost in the process of going from one substance to another. So we got 0.046 moles of LiBr. Right? What we need to do is we want to figure out moles of LiCl. Right? So what we're going to do is I'm always following my units. If I have something here written in, I'm going to follow it down here. It's going to be exactly the same label. It won't be any different. So I'm going to put moles of LiBr. I'm trying to go to here. That label is moles of LiCl. Going from here to here. So that'd be moles of LiCl. Now, anytime you do mole, or you got moles in both places, you use the numbers in front of your balanced equation to plug in there. We're used to putting 1 all the time when we do moles. But now we're doing a comparison between every mole value within the reaction. And so we're going to put a 2 here, since there's a 2 in front. And we're going to put a 2 here, since there's a 2 in front of that one. And when we do that, we realize that it doesn't change our initial number of moles. It just allows us to find the moles of our new substance. So it's 0.046 moles of LiCl. Any questions at that point? So, let's say, for instance, I wanted to go to chlorine instead. Let's say, hey, you know what? I want you to find chlorine too. I want you to find the amount of moles of chlorine that's required. Well, it's same starting point. Okay, this isn't a problem you had to do, but I wanted to show you that scenario. So same starting point, 0.046 moles of LiBr. Then we transition, and down below I'm going to put LiBr again. Some of you will fight of showing your units and your labels, and you have to, you need to know what you have to cancel out. Now I want to go to chlorine, Cl2. So I'm going to go moles of chlorine up above. And I see that for every 2, I need just 1 chlorine. So it's going to be half as much. I'm required half as much, 2 to 1. It's half as much. So my answer for that one, if I was asked to solve for that, is 0.023 moles of chlorine. Any questions? Okay, I'm going to give you the answers. You guys can go back and do this later because I'm not going to spend the time of going through 167. Okay, your answers for 167, 27 moles of H2SO4. 27 moles of H2 for letter B, and 9 moles of aluminum sulfate for letter B. You had to do both. You had to go to both products. So, questions on that? Okay. All right. So, what I'm doing is the basics. You have to do this every time somewhere in your setup. You have to do that. And you have to label them. If you don't label them, you're not going to be successful. Okay? And you're going to get mad at me. You're going to get mad at, I can't do this. And I say, yeah, you're right. You're not labeling anything. I can't really say, you know, you're setting it up wrong, and you got to make sure you got your labels there. Okay? If you would, in your book, we're going to do 2 different problems here today, and it incorporates these setups in every single problem that we're going to do. I need you to turn to where you're given some information on what we're trying to solve for. Turn to page 306. 306. Okay, this is the equation I'm going to write out for you. Okay, so I'm going to give you the equation that we need to do. Most of the time on the problems I'm going to give you today to do, you'll have a formula or an equation. And some of them will be balanced. So you guys know how to balance. We're not going to have you do that step. You're going to know how to do that. The equations are all really shown there. And so I'm going to state the problem or what we're trying to find here. Okay? It's stated in sample problem B, but I'm just going to go ahead and simplify it and put it in there. We're going to say what mass in grams of C6, that's glucose. So when they say glucose is produced from 3 moles of water. Okay? Any questions with that? So, what do you think I'm going to start my problem out with to solve for? So, what I'm going to use this as a map, and I'm going to go, okay, I'm going to make this down below, I'm going to make it 3 moles. And what I want to do, and the reason why I'm going to do this, I'll explain here in a second. I want to find grams of this stuff. Okay? So I want to go from H2O to glucose in grams. Okay? I need to always go through moles to get there. I need to go here first. So I need to do a mole-to-mole problem. This will be an excellent opportunity for you to show me that you can do a mole-to-mole problem. So the first step of what we're doing here is doing a mole-to-mole problem. Let's label this problem that I'm doing. Okay? The first one you did was mole-to-moles. This one is a mole to, and we'll say moles of A to mass of B. It's a mole to mass problem. Okay, so go ahead and label that mole of A to mass of B. That's the type of problem that we're solving here. Okay, so what I want you to do, solve for moles of C6H12O6. And then stop. Okay, so then what we do, we'll do moles to moles. So we'll go moles of A to moles of B. See, we can't go to mass right away. We've got to go through moles to do that. So we're going to go 3 moles of H2O. Then our first step, we're going to go moles of H2O. Now if you realize I'm not going to put any numbers in until I get my moles in there. That's what I like to do. Then you put moles of C6H12O6. So then the numbers that go in there would be 6. And then here, there's a 1 in front of glucose, so I put a 1 there. That's where I get my numbers, just like I did for today. Okay. Moles of H2O cancel. Now if I stop there, I get 0.5 moles, right? Okay. I would be here and I could put 0.5 moles. But I don't want to stop there. I want to go on to find the grams. So my next step would be I follow my units. I'm going to put moles of C6H12O6 down here. And then up above I'm going to put grams. Because I can go grams of glucose and from moles to grams of glucose. And that's what I'm going to do on my last step, and then I can get my answer. This last step you've done many, many times, changing grams or changing moles to grams. You have done the last step a lot, previous chapters. So what am I going to put in front of this moles of C6H12O6? 1. And why 1 is because I'm finding the molar mass of it. So anytime you got grams and moles you're relating, you always put 1 for moles. The only time that you put numbers other than 1 is when you do the mole ratio. So in here I'm going to calculate everything. I'm going to take 6 times 12.01, find the molar mass of it, 12 times 1.01, and then 6 times 16 is 96. I add them all up, and that gives me the molar mass. It's 180.18 grams. And guess what I have? What's my unit? Grams of glucose. I am done. I just have to multiply it out. So you guys multiply it out and see what you get as an answer. Hopefully you can multiply it out right. The numbers on bottom need to divide, and numbers on top need to multiply. Okay? So go ahead and multiply that out and see what you get. It's in the book, so you can double check. We're doing the problem in the book, so what should it be? 90.1 grams, right? Remember, stochiometry means mass relationships. And that's what we're doing. We're looking at moles, and we're trying to do mass relationships. So that's my answer. Okay? And that's all you're doing. Do moles, and then go to grams. So I've got a third type of problem. It's the opposite of what we just did. So it's not like it's going to be foreign. You don't know what you're doing. We're like switching this arrow. And we're saying we're going to go from a mass of a B to moles of A. Okay? Is what we're going to do. So go ahead and turn over one page to 309. Okay? Page 309. Okay? And then we're going to go ahead and balance this equation on 309. And it's given for us there. It's ammonia plus O2. We're at the top, sample problem D. we're going to produce nitrogen monoxide and water. Okay? And I think to balance it real quick, they did it for me last period before. I think this was 5, and this was 4, and then this was 6. Okay? You guys know how to balance, so you would take the opportunity to balance that. It's not like we've done it, proved it last chapter you could do it. Alright? So the question I'm going to ask is, using 824 grams of NH3, how many moles of NO is formed? Okay, so what I'm going to do, I always like to put grams above my equation and moles down below. It's just a way of keeping track and separating grams and moles for my just understanding where I'm at. So I've got 824 grams of ammonia. And I want to go down here and find moles, because I like to put moles on bottom. It's no reason on setup and dividing and that. It's just kind of allows me to know where I need to go. I need to go here. So does anybody know what first step I need to do to get here? Because it's 2 steps. So what do I need to do on the first step? Yeah.
Grams of nitrogen to moles.
Right. So I'm going to have to take, so again, this one we're doing mass of A to like moles of something else in the equation. And we'll say moles of B. So what I'm going to have to do is I'm going to go 824 grams of NH3. And then I probably put grams down here of NH3. And up above, I'm going to have to put moles of NH3. So anytime we got grams and moles we're relating in a conversion, I'm always going to put 1 in front of NH3. And you say, well, wait a second, there's a 4 in front of NH3 there. Why are you not putting a 4 there? And the reason why I don't use that until I do a mole relationship. And I'm doing a gram to mole relationship. So I got to look up NH3 and I calculate it. And I take 1 nitrogen and 3 hydrogens, I add them all up, and I get 17.04 grams to 1 mole. And now it's really easy, right? Because now I'm doing a mole-to-mole problem. So you go ahead and finish that one out. Finish that out, see what you get for an answer on moles of NO. Okay? Point. So again, the next step, you got grams you canceled. Now you got moles of NH3 you canceled. And then in this step, we do a mole-to-mole relationship. That's when you use the numbers in front. Okay? And then when you get that answer out for number of moles of NO, you should have 48.4. Is that what you get?
Yep.
Good. So you need practice. Without me showing you step by step, you need to go through the process of doing it. And so I've got 4 problems for you to do for Monday. And they are problems page 890. And they're problems 169 through 172, and they're all A's. There's like an A and B. So you just do the A. Okay. And there's 2 of each. 2 of each were the problems that we just did. So there's 2 of each. So do that for Monday. Okay, you guys got a good 15 minutes to get that done.
Do you want me
Why don't you do a problem or two and then you can go down.
to? Okay.
Okay?
I put my pass there for mine.
All right, thank you. Did you get that test done yesterday then?
Yeah.
Good.
Can I finish up?
Yes, you can.